Welcome to Spectrum Sphere, your gateway to a world brimming with knowledge and imagination. We delve into a vast array of subjects, from the marvels of science and the beauty of art, to the rich tapestry of history and the cutting edge of technology. Don't forget to hit the like and subscribe button to join our community of explorers on this journey of discovery. Delving into the annals of technology, the concept of computer programming dates back to the 19th century. It's a journey that began with looms and punch cards, evolving into complex languages that now power our digital world. Let's uncover how early innovations laid the groundwork for our current technological landscape. In the realm of programming origins, we encounter Ada Lovelace, recognized for drafting the first algorithm intended for processing on a machine. In the mid-1800s, Ada's work with Charles Babbage's analytical engine established the theoretical foundation for future programming languages, truly entitling her as the world's first programmer. Following Ada Lovelace's pioneering algorithms, the introduction of binary code became a pivotal moment. The binary system, using just two symbols, zeros and ones, allowed for the representation of complex instructions in a form easily processed by machines, setting the stage for the development of programming as we know it today. Moving from the esoteric strings of zeros and ones, assembly language was born, acting as a stepping stone between machine code and high-level languages. It provided a more understandable set of instructions, which were still closely tied to the hardware, but allowed programmers to use symbolic representations instead of binary. After grappling with the complexities of earlier programming, the 1950s heralded a revolution with the development of FORTRAN, short for Formula Translation, by IBM. As the first high-level programming language, FORTRAN allowed scientists and engineers to express problems and solutions in a more natural and mathematical notation. Shifting from scientific to commercial use, the 60s brought us COBOL, the Common Business-Oriented Language. It was engineered for business finance and administrative systems, crucial for government and corporate data processing. COBOL's English-like syntax was designed to be readable by non-programmers, thus bridging the technical divide. In the realm of artificial intelligence, the late 1950s marked the arrival of LISP, a language tailored for AI research. Short for LSP processing, LSP's unique features like recursion and symbolic expression processing made it a stalwart in the development of AI programs, maintaining relevance even today. Transitioning from LISP, let's delve into ALGOL. Introduced in the late 1950s, ALGOL, which stands for Algorithmic Language, significantly influenced many programming languages to come. It introduced code structuring concepts like nested functions and block structures, laying the foundation for the structured programming paradigm that's ubiquitous today. As we witnessed the evolution of programming, BASIC emerged in the mid-1960s, becoming a turning point. It stood for Beginner's All-Purpose Symbolic Instruction Code, and its simplicity was intentional, aiming to make programming accessible to a larger audience. BASIC truly democratized programming, allowing more people to partake in the computer revolution. The landscape of programming was forever changed by the rise of C in the early 1970s. Birthed from the need for efficient system programming, this powerful language allowed for the creation of operating systems, including the famed Unix. Its portability and direct access to hardware made it essential for software development. As a pivotal advancement in programming, the 1960s brought forth Simula, the first language designed with object-oriented principles in mind. It introduced the concept of objects, classes, and inheritance, allowing programmers to model complex systems more intuitively. Simula set the stage for future languages that would embrace object-oriented methodology. Building on the concepts pioneered by its predecessor C, C++ emerged in the 1980s. It quickly gained popularity for its object-oriented features, such as classes and polymorphism, combining the efficiency of C with new levels of abstraction. This evolution made C++ a staple for complex software development, from operating systems to game engines. In the late 1980s, Python made its debut. introducing a design philosophy emphasizing code readability and simplicity. Python's syntax allowed programmers to express concepts in fewer lines of code compared to other languages, making it an ideal choice for beginners and for applications across web development, data analysis, and artificial intelligence. Java surged into the programming world in the mid-90s, revolutionizing the concept of write once, run anywhere. This cross-platform functionality meant that Java code could run on any device with a Java virtual machine, breaking down barriers between operating systems and fueling the rise of Internet applications. Transitioning from the rise of Java, Microsoft introduced its own contender in the realm of programming, C#. Debuting in the early 2000s, C# was designed to be a versatile language, blending the efficiency and power of C++ with the simpler syntax of Visual Basic, marking a new era for Windows applications. As we move towards the dynamic web era, scripting languages started to gain prominence. PHP, which stands for Hypertext Preprocessor, made its entry as a server-side scripting language that was easy to learn and offered powerful features for web development. It quickly became a staple in creating dynamic and interactive websites. Moving into the realm of dynamic web content, JavaScript emerged as the game changer. It's not an overstatement to say that JavaScript transformed web development, allowing developers to create interactive, rich web experiences. Today, it's virtually ubiquitous, powering the client side of the most visited sites on the web. As we embrace the digital age, the aesthetics of the web took a leap forward with the introduction of CSS, or cascading style sheets. CSS became the cornerstone of web design, allowing developers to craft visually engaging sites with greater ease. This evolution marked a pivotal moment in creating the rich online landscapes we navigate daily. Shifting our focus from systems to people, Ruby emerged with the core philosophy of boosting developer happiness. Created by Yukihiro Matsumoto, Ruby combined parts of his favorite languages to build something simple, elegant, and enjoyable to write. Ruby's contribution to software engineering prioritized the human experience behind the code. Now let's delve into a significant shift in the programming landscape with the creation of Haskell. As a pure functional programming language, Haskell brought a new paradigm that emphasized functions and immutability. It catered to complex problem solving where side effects were minimized, ultimately paving the way for safer and more robust code. Moving on in our programming odyssey, we witnessed the development and rise of SQL, or Structured Query Language. This specialized language revolutionized how we interact with databases, allowing for the management of vast amounts of data with ease. SQL's introduction marked a profound advancement in data retrieval and manipulation. In the realm of modern programming, languages like Go and Rust emerge with a promise of robustness and efficiency. Go, designed by Google, prioritizes simplicity and performance, specifically for cloud services. Rust, on the other hand, emphasizes safety and concurrency, targeting system-level tasks where reliability is critical. Both advocate for more reliable code bases. Swift drastically transformed iOS development by combining the performance of compiled languages with the simplicity of popular scripting languages. Introduced by Apple, Swift made it easier to write reliable code by handling many common programming errors by design. Its introduction accelerated app development and enhanced software quality on Apple platforms. In recent years, data science has surged in prominence, furthered by the growth of big data and analytics. The R language has become a cornerstone for statistical analysis and graphical representation, favored for its ease of use and comprehensive library support, empowering professionals to transform complex data into actionable insights. As programming projects grew more complex, version control systems became vital. These systems manage changes to code, allowing multiple contributors to work simultaneously without conflict. They facilitate collaboration and track revisions. Foremost among these, Git has revolutionized how programmers store, share, and maintain their code repositories. Looking ahead, the future of programming languages seems boundless. We expect further advancements that enhance code efficiency, security, and ease of use. Innovative languages will likely emerge, designed for new computing paradigms like quantum and biological computing, reshaping how we think about solving problems through code. Artificial intelligence is revolutionizing programming too. With AI, we're seeing the development of smarter tools that can predict code, automate tasks, and even find and fix bugs. It's paving the way towards more intuitive programming environments, where coders can collaborate with AI to write better, more efficient code. As we venture into the era of quantum computing, programming languages are poised for a transformative leap. Quantum computers operate on principles that differ vastly from classical computers, necessitating new languages with the ability to harness this power. These emerging languages will need to cater to quantum logic, offering a paradigm rich with possibilities and complexity, fundamentally altering how we think about coding problems and solutions. Now, we turn the spotlight to you, our Spectrum Sphere community. Your curiosity fuels our exploration. So tell us, what topics are you eager to unravel? Drop your thoughts and ideas in the comments below, and let's embark on these knowledge journeys together. Your insights shape our quest for discovery. Thank you for delving into the chronicles of programming languages with us today. If you've appreciated the journey, consider giving us a thumbs up and subscribing for more from Spectrum Sphere. Don't just watch, join the discovery. Until next time, keep exploring the diverse world of knowledge with us.